Hey everyone, this is Subnet Zero and welcome to my channel. In this video, we will be taking the complexity up a notch and we will get our foundations more solidified, okay? And also, I will walk you through how this workflow can be implemented, okay? So essentially, let me first inform you this workflow is like creating a blueprint. Suppose if you're constructing any building, you're not going to start randomly constructing a building out of nowhere, right? You will need to have a design, a blueprint of how it works. So this will essentially help you to how to create a network layout, how to create a blueprint of the same before you put it in implementation. Okay. Also, I just want to cover one thing for fixed length subnet masking and variable length subnet masking, how that looks like in as a visual representation. Yeah, you see this? This 256 addresses fixed length is like each department. This is Office 1, Office 2, Office 3, Office 4, but let's replace that with department. Department 1, IT, Department 2, Sales, Department 3, HR, Department 4, Admin, for example. So they all have 64, 64, 64, 64 blocks of the entire chunk in each of them. They're all equally divided. While in variable length subnet masking, they're all divided as per requirements. Okay, like it's this one you see over here. It's not like a fixed amount. It's not like 64 across the board. It's different numbers, depends upon the requirement. For example, of Office 1, not Office 1, Department 1 or IT department, let's say, if has 64, then a smaller two chunks will be the other two, which require slightly less. So I'm sure this clears up any doubt. Okay. So let's open up a pink circle, the pink circle which represents your private company. Okay. So let's take here. So let's IT, and let's say if IT needs 80 computers. Okay. This one will be HR, and HR will need 30 computers or devices. This one is sales. It needs 20 computers. This one is finance. It needs 12 computers. Yeah. This one is CCTV. It needs eight computers, devices. Okay. When I say computers, I mean it can be any device. It can be mobile. It can be laptop. It can be computers. But I'm just using let me use the term device to make it easier. Okay. And this one is printers. Let me just, yeah. Printers would need 5 devices. Okay, 5 printers. So let's say if our office is divided in such a setting, how will we divide the subnetworks? So let's open up our design workflow, the VSLM design workflow. First one we've already done. How many departments require their own network? We already have over here. We need 6. How many devices does each department need to support? Also, we have done this. Now, the third part. This is the meat of the calculation, okay? So first, we will do the one which has the largest amount of devices, that is the IT. Okay, so IT has 80 devices. So let's start with our usual 192. We are taking the example of 192.168, okay? 192.168.0.0. What will be the slash notation? Let's open up our cheat sheet, and we need 80 devices. Let's open up this. In our row 16, which one would it support 80 devices? We will take up /25 because it supports 126 devices. It will be /25. Yeah. And then its calculation would be this. Yeah. This one would be 192.168.0.0. That would be the network address. 192.168.0.127 is the broadcast address. Everything else is in between. If you do not know how to calculate this, please go back to the previous videos, the CIDR calculation. That is very useful in clearing all doubts. Okay. And the total of this would be 128. Okay, so 128 IP addresses this can support, including network and broadcast. This information will be useful later on. Okay, so let me just color code this and put it on the side. Okay, now next we will do is HR. HR will be 192.168.0.128. Why 128? Because this one ends with 127. Okay, what will be the slash notation of it? Because we need 30 devices. Okay, let's open up our cheat sheet. Which one supports 30 devices over here? /27. Exactly, it supports 30 devices. So we will take here /27. And the calculation of it would be 192.168.0.128 to 192.168.0.159. Yeah, and the total it would support is 32. Total would be 32 IP address this network block can support, including network and broadcast. Okay, let me color code this in green. Now we will do sales. Sales will be 192.168.0.160. Why 160? Because this one ends with 159, okay? And the slash notation would be, we need to support 20 devices. Let's open up our cheat sheet. Again, it will be /27 because it is the lowest number which can support 20 devices, yeah? We can't take /28 because it's only 14 devices it can support. /27 can handle 30 devices. So that means 30 slots. That means enough slots for 20 devices. Let me just add the range of it. Yeah, this is the network address. This is the broadcast address. Everything else in between would be usable ones. Okay, and the total of this would be 32. Yeah, let me color code this in green. Let me put this at the side. So now we are sorted with sales. Okay, so these three we have done. Regarding finance, CCTV, and printers, I will fast forward it a little. The reason is I want to go to step 5 and step 6 to show how the parent network is selected and how after that we can put this in implementation, okay? And this one over here, we have over here, okay? So now we have all the information, whatever we need for all the devices, okay? Now, let's total up this one, the total. Let's total the total over here. Let's total all this up, okay? Let's open up a calculator. So, 128 plus 32 plus 32 plus 16 plus 16 plus 8. How much do we have? 232. So, in our cheat sheet, /24, this can take we have 254 devices and slots for this, okay? So, and 256, the total amount it can take. So, this is the safest bet of the parent /notation, parent CIDR that we can select, okay? So the parent of here would be 192.168.0.0 /24. This would be the parent IP address and CIDR notation that we will choose for this entire organization, okay? And this entire organization, it would be this, okay? One more thing I just want to add over here. After all the calculation, we will still have this much remaining. Let me just, between 192.168.0.232 to 192.168.0.255. This will be after we have allocated the IP addresses of this to each department. We will still have this much. We will still have this much remaining. So this will be useful like in the future if you want to, if there is growth, if there are more employees hired, or if the department is like expanding, this would be these extra, spare IP addresses would be very useful. So in our workflow, if we see, we have done part 5. That is here. Let me just we have done the 5th part. That is choose the smallest parent network that can accommodate all the child subnets. Yeah. Now, this is the 6th part, which I want to show you how this would work. Yeah, I just want to give you a brief representation, a visual representation of how this would work, okay? So this one is the entire block or the entire private network, the entire block of the private network that goes from 0 to 255, okay? How this would work. So IT would take up the half of the chunk of the network given our requirement. Then would be HR, then would be sales, then would be finance, then would be CCTV, then this would be printer. I did not have much space, so I've just, did an arrow and call this printer, okay, of 8. This will be the unused section. So this is like, it will give some space for scalability in case if there is more staffing that comes up, okay? So why is this workflow useful? This one that you see over here. Now, we have pretty much done all the 5 parts, okay? Now, the 6th part, allocate all the child subnets from the largest to smallest. Now, what does this mean? Now that we have our layout, okay, how this would work. Again, think of the building analogy. You're not going to just randomly construct a building, right? You will need to have a blueprint of where the building will be constructed, how it will be constructed, how much space you'll allocate to each room. Yeah. Similarly, so right now, this is just you are creating a design, okay? A blueprint. So, for example, think of it like a pyramid, okay? So, first we will do the foundation, okay, which is the HR, IT, which department should be allocated which. Yeah. So after this, once we have all information, the one on top, this block, after we have all the information, this will be the parent block. Okay, this will be the parent block that we have calculated. That's 192.168.0.0/24. Okay, and this one is that we have divided IT, HR, all of that, okay? Sales. You have divided them all, okay? So based on the calculation of all the departments at the bottom of the hierarchy, once we have calculated all the details, we can after that select the parent. Once we have selected the parent, after that we can put it in implementation. As in real life, we will know this parent to be selected. We can then go to the next step of allocating all the departments their designated network blocks. Make sense? So I hope this was useful. So this is like a slightly complex example that we took real world requirements or real world scenario of how this would work. Okay. So I now hope that this video will help you solve further complex examples. It will make network layout of in real world much easier. This cheat sheet is available, so is the design workflow. Now somebody asks you to create a network layout for a small organization. Now you should not flinch. Now you should not hesitate. Now it should be on your fingertips, okay? In fact, my recommendation for you would be to go for further complex examples. And the more complex examples you provide yourself, the more solid your foundation would be. As I say earlier, the wacky the examples, the solid your logic. The wackier the example, more solid your logic. Okay. So I hope this was useful, and in the next video, I'll cover subnet masking, okay? So I hope this information was useful, this video was useful, it cleared all your doubts, and I'll see you in the next one. Bye.